All right, hey everyone. Today we are going to talk about factoring. Not everyone's favorite, but definitely something that's very important for this class. So, factoring quadratics, here we go. All right, so first off, oops, I meant to erase that. That's okay. That was from my first attempt at this video and it didn't go so well, so I had to restart. It's fine. Okay, so anyways, we're going to talk about the four main types of factoring. Yes, there are other types of factoring that we are going to talk about in this class, but not right now. All right, these are just the four types that we're going to see throughout this entire school year. All right, and they are going to be your GCF factoring, which is a greatest common factor. Then we have factoring with a leading coefficient equal to 1, which is probably one of the easier types of factoring. We have factoring with a leading coefficient not equal to 1, which is nobody's favorite. And then we have something called the difference of squares, which you might not have heard about before, depending on your Algebra 2 teacher, but it's a very easy way of factoring if you just have a binomial. So we'll get into that one. That's definitely like a special circumstance type of factoring. Anyways, starting off with our greatest common factor, this is any time that you have multiple terms and you have something in common and you want to kind of pull or divide out that common piece. All right, so this is when you, I don't know, it's not technically dividing, right? Because you're keeping it there. It's not going anywhere. It's going to stay out front, but you're dividing out, right? So divide out those common or like pieces from each term. All right, so this is, like I said, you're looking for things that are in common. You kind of pull anything that's in common out front, and so you kind of have simplified your expression that you have going on there. Okay, now factoring with a leading coefficient equal to 1. Depending on who your teacher was last year, you may have factored a bit differently. But I like to use one standard way of factoring so we're all on the same page. All right, so those of you who have heard of the box method, that is the method that I use for factoring. All right, so remember our quadratics, right? We have ax squared plus bx plus c. All right, so when we do our box, all right, what you're going to do is you're going to simply put that ax squared piece right here. All right, and then the c piece goes down here. And then those two boxes, this is going to be your bx term split. All right, so what goes in here is going to be whatever adds to b and multiplies to c. All right, so you're looking for a special pair of numbers. All right, so you're going to ask yourself, okay, what two numbers add to make b but multiply to make c? And that's what you're going to put in here. All right, these two boxes, all right, that you're going to have, they should add up to equal that bx term. All right, so it's kind of a little bit of a guess and check kind of thing, because that's where you're, like I said, you have to find the correct combination. So two numbers that are going to add to b and are going to multiply to c, and at the end they should add up to make your bx term. We are going to do examples, so if that was kind of weird, it's okay. All right, so the next method is very similar. So it's factoring when you have a leading coefficient not equal to 1. All right, so in this instance, this first one we're looking at, that a value is going to be a 1. So there's nothing there. That's what I mean by a leading coefficient. Right, so the leading coefficient is the number that's out front of our equation. All right, so in this next instance, we don't have a 1 in the front. We have some other number next to our x squared. Now, like I said, it works very similar to the leading coefficient of 1, except there's a strange little extra piece. Now, again, Depending on who you had for Algebra 2, you may have done this differently. This is the technique that I use. If this is not your technique, that is fine. As long as you can factor and you get to the same answer, that is our end goal. All right, I definitely am not one of those teachers that says you have to do it my way, or otherwise it's wrong. I am totally fine with, as long as you're doing it by yourself and you're not cheating and looking at a neighbor or calling a friend and it's the right answer, then you've done it right. Okay, so if this is not your technique, don't stress. You don't have to do it this way. This is just how I like to do it. So I like to call this the X box method, because we're going to do an X and we're going to do a box. All right, so again, we have that ax squared plus bx plus c, and we are going to start pretty much the same. So we are still going to put ax squared in this top corner. We're still going to put our c down there in the bottom corner, and these two boxes are still going to add to equal that bx term. All right, now, how we have to find this middle term, that's the part that the x is going to help us with. All right, so instead of just adding to b and multiplying to c, it actually has to multiply to whatever a times c is going to be. All right, so you have to first multiply a times c. All right, and that's the number that you want to multiply to. All right, so since we don't have a 1 out front, we have to take into consideration that number that is there that's out front. So first we have to multiply a times c, and that's what we want to multiply to. And then on the bottom, we still are just going to try and add to get the b value. So we multiply a times c, and that becomes what we're multiplying to. And then we're still trying to add up to make b. All right, and then our numbers that work are going to go on either side. So you don't actually have to draw the x. It helps some people if you're more of a visual person, but you don't have to do that. All right, so these numbers right here, like I said, it has to add to make b. So it's still going to add to make b, just like it did before. And now it has to multiply to a times c. All right, so instead of just multiplying to c, it has to multiply to make a times c. That's the only difference. And then you just fill in your box. All right, and again, we are going to do an example of this, so if that doesn't make any sense, we'll do a practice one. All right, last but not least is difference of squares. Now, some people, if you really just like to stick to one method, you can technically use the factoring X box method or box method depending on the problem, but it is not the easiest way. All right, so difference of squares, this only works when you have a binomial, all right, meaning two terms. All right, so works with binomials, so works for binomials. All right, so two terms, all right, they have a minus sign in between them. All right, so with a minus sign in between. All right, the last thing you have to look for is it doesn't work with all numbers. All right, this only works when you have perfect squares. And if you don't know your perfect squares, definitely some things that you're going to need to remember. All right, you should know your perfect squares at least up to 12, maybe 13 if you're super fancy. All right, but these are just numbers like 4, 16, 25, 100. All right, so they're the numbers that when you take the square root of them, you don't get a decimal. All right, so you also need perfect squares. All right, now I know this seems like it's a very specific set of problems, but the crazy part is you actually come across this all the time, especially when we're doing our factoring with our trig stuff. So it's good to practice it with just numbers so that when we do get to doing it with trig functions, it's not as scary looking. All right. But the technique works like this. So if you have this situation, so we'll just use letters right now. Stop, don't do that. All right, so we're just gonna do it with letters and then we'll put numbers in here in a second. So let's say you have a squared minus b squared. Okay, cool, doesn't matter. All right, if you were doing difference of two squares, this is what you would do. So a is a perfect square because it's just a squared, and b squared is a perfect square because it's just b squared. All right, and we have a minus sign in between, and it's a binomial because we only have two terms. All we need to do is we're gonna set up our parentheses. We're gonna make two. One parentheses will get a plus in between, the other one will get a minus in between them. To fill the other pieces, all we do is we take a square root of each of our terms. So we're gonna do, what is the square root of a squared? Well, the square root of a squared is just a. That's gonna go in the front. That's it, all right? And then the next part, to get our second piece, we're just gonna take the square root of b squared. And the square root of b squared is b. So we just put a b right there. That's it, that's all you have to do. All right, so yes, it does really only work in very specific instances, but if you can remember it and you can catch it, then it makes your life really easy because it's super fast. Okay, let's do these example ones. All right, so we have 3 example problems that we're going to do. Oh, stop scrolling. All right, we have 3 example problems that we're going to do together, and then we'll be done with the video. So let's do it. All right, so our first one. All right, so it says factor the following quadratic expressions, and then it says expression means no equal sign. So remember, we are not solving. This is not equal to anything. We just want to factor. All right, so that's important. If something says to solve, that generally means there's an equal sign in there, all right? But we're not solving. We are just factoring, all right? So we're just practicing factoring. We'll get to solving in the next video. Okay, so we look at number 1, and we have 4n squared minus 4n minus 288. All right, now, the first thing I notice is that we have a 4 and a 4. All right, so I'm wondering if 288 is also divisible by 4, and let's see if it is. So let's go to our calculator. All right. I've lost my mouse. Sorry, guys. Hold on. I found it. Okay, so 288 divided by 4. Yes, it is. It's 72. So that tells me that I have a greatest common factor that I can pull out, and that is 4, because every single number in this expression is divisible by 4. So first I'm going to rewrite it. All right, so first off, I have 4. I'm pulling a 4 out from everything. So I'm going to be left with n squared minus n minus 72. All right, because I've pulled 4 out from everything. I just divided everything by 4. Now that 4 doesn't go away, it does stay out front, because remember, if we were to go ahead and distribute the 4 back in, we should always come back to what we originally started with. Okay, now, next I have to look and see what else I can do. So if I look at my n squared minus n minus 72, I notice that I have a leading coefficient of 1. There's a 1 in front of the n squared, which means I can just use that box method, which is what I'm going to do. So I'm going to draw my box. All right, I'm going to put my n squared in the top corner. I'm going to put my minus 72 in the other corner. All right, so now I'm looking for 2 numbers that multiply. So I want to multiply to equal negative 72, and I want to add to equal negative 1. All right, so we need to think of 2 numbers that multiply to negative 72 and add to negative 1. It's going to be 8 and 9, all right? And the 9 is going to be negative because it's the bigger one, and I want my middle term to be negative. So it's going to be negative 9n and positive 8n. All right, so if we add them together, we get negative 1, and if we multiply it together, we get negative 72. All right, if it takes you a little bit more time than that, that's okay. Do some guess and check with your calculator. You don't have to know all of them right off the top of your head, but you'll get better at it with practice. Okay. Next, the factoring part. We're going to start with this top left corner where the n squared is, and I'm going to look at the n squared and the negative 9n. So I'm going to look at this top row. All right, and I'm going to GCF. So what does n squared and negative 9n have in common? Well, They just have n in common. All right, now I'm going to do like reverse multiplication. So I need to know n times what would make n squared? Well, n times n makes n squared. So I put that n above my box right there. All right, and then I'm going to keep kind of doing that. So it's like reverse multiplying. So now I'm going to look in my row. So n times what is going to give us negative 9n? Well, n times negative 9 gives us negative 9n. All right, now I have to go down. So now I need to know n times what? So now I'm looking down, like right here. All right, so now I need to know n times what is going to give me 8n. Well, that's n times 8, which gives me 8n. So my factors are going to be these pieces outside. All right, so my function factored all the way, don't forget the 4 in front, is 4 parentheses, n plus 8 and n minus 9. That is my final answer. All right, cool. Moving on, number 2. All right, so number 2, first thing I want to do is I want to check to see if I have any greatest common factors that I can pull out from my function, or my expression, I guess is more appropriate. All right, so I see there's a 3. All right, so I want to know, okay, I have 3. Is 48 divisible by 3? You may already know this, but if you don't, I'm going to go ahead and do it. So 48 divisible by 3. Let's see if I can just pull that 3 out. It is. It's 16. So I'm going to go ahead and pull it out. So I have 3. I'm GCFing that out front. Now I have an n squared and a v squared. Those are not like terms, so I have to keep those. All right, so then I have n squared minus, and then we said 48 divided by 3 is 16. V squared. Okay, now I look at these. I know n squared is a perfect square. I know v squared is a perfect square. Is 16 a perfect square? Yes, it is. So this is that difference of squares. All right, watch how easy this is. The 3 stays out front. Then I'm going to make my 2 parentheses. One gets a plus, one gets a minus. All right, and then I'm just going to square root each piece. So I'm going to first square root the n squared. The square root of n squared is n. That goes in the front. All right, and then I'm going to square root the 16v squared. All right, you're not square rooting the negative. The negative comes in when we put the plus and the minus in our parentheses. All we're square rooting is the actual term itself. So we're just square rooting 16v squared. Well, the square root of 16 is 4, and the square root of v squared is v. So we have a 4v right there. And guess what? We're done. That's our answer. Cool. We have one problem left. And it looks like there's a bit of a typo. We're not doing this bottom piece, so don't look at that. We're doing that in the next video. All right, it looks like I have a typo. So I'm pretty positive this should probably be v squared right here, not x squared, because I don't think I want to have more than one variable. Okay, so it's a v squared. All right. Now for this one, looks like it's going to take a little bit of guessing. All right, so the first thing we need to do is we need to find out what things they have in common. It definitely looks like there is something in common because I can at least pull out that v squared because I have a v squared in each piece. I also think there's a number that I can pull out. So see if you can figure out what number we can pull out, our greatest common factor from each one of these pieces. Okay, so I just paused, hopefully you guys did too, and I found that the greatest common factor that I could take out of this problem was 4v squared. So I can pull a v squared out from everything, and I can also pull a 4 out from everything. So that is my greatest common factor that I'm just going to leave out there in front. Now, this is as simplified as I could get it before factoring. So we do have some pretty big numbers that we're going to work with here, and that's okay. We have a calculator, so that's all we need. All right, this has a leading coefficient that is not equal to 1. So I have a 9 out front. So what I'm going to do is I am going to do my X box method. All right, you don't have to use the X. If you can do this without that, that's fine too. Remember, it's all about you and how you learn. Choose your own adventure. All right, so I'm going to go ahead and I'm going to draw my box. All right, I put my 9v squared up in there, and I put my 20 over there. So now I need to figure out, all right, so if you like the x, use the x. If you don't like the x, that's okay. But I need two numbers that multiply to equal a times c, and are going to add, so multiply to make that, and then need to add to make b. All right, so it is going to be a little bit guess and check. So first thing I need to do is multiply a times c, which a times c, 9 times 20, that's 180. So these two numbers have to multiply to 180, and they have to add to my b value, which is now 88. All right, so take a second. I'm going to pause, and let's see if we can figure out these numbers. All right, so remember, multiply to 180 and add to 88. Okay, so also, because I dropped a negative, just want to remind you guys, so there is a negative right here. All right, so this should be negative, reverse, erase. All right, so it should multiply to, negative 188, and this is a negative 20 right here. Okay, sorry about that. Don't drop your negatives, it's bad. That's like the second time I've done that in these videos. Okay, so multiplies to negative 180 and adds to 88. So the magical numbers that I found were 90 and negative 2. So 90 times negative 2 does give me negative 180, and 90 plus negative 2 does give me 88. So those are the numbers that I'm going to put in my box. So I have 90v and I have negative 2v. All right, so now we just need to do that kind of greatest common factor stuff for my box. So I always start with looking at the top row. What can I pull out? What GCF does 9v squared and 90v have in common? Well, 9v. All right, now I'm going to go through and I'm going to like reverse multiply to see if I can get each box. So 9v times what gives me 9v squared? Just v. All right, 9v times what gives me 90v? Well, that's 10. All right, and now I'm going to go down. All right, so now I want to multiply down. So v times what is going to give me negative 2v? Well, negative 2. All right, so now I have my factors. All right, so my factors are going to be 9v minus 2 and v plus 10. Now we can't forget that GCF that we took out a long time ago. So out front, we are still going to have, go away keyboard, 4v squared. And that is our final answer. All right, so that is it for this video. We are done with factoring. Hopefully that helped. Next video, as you can see, we're going to do solving for x-intercepts. Bye, guys.